In this section, we're going to analyze finally those controls that are going to allow us to create our applications with .NET MAUI, and we can group these controls in different categories that we're going to see throughout this section. Let's start with the presentation controls, which are those controls that are going to allow us to improve the graphical interface or that are going to allow us to display some type of information to the user without the user necessarily having to have some type of interactivity with these controls. We're going to create then a new project to which I have called Controls Demo. I'm going to proceed to create this project, and once the project has been created, we're going to create a new content page. And we're going to call it, for example, Presentation Controls Demo. It is going to be the content page with which we are going to work these presentation controls. Let's go to app.xaml.cs and let's indicate that we want this page to be the initial page. The first presentation control that we're going to see as part of the content page is a control called Box View. We're going to leave the stack layout as part of the content page, and we're going to write the term box view. This way, we can visualize how this control is going to be seen by default in the application. Let's start the execution of the application. Here we can see the application, and as we can see, no control is seen as part of the graphical interface, so we must assign some additional properties for our box view to be seen. The properties are, for example, one called background color. To set the background color, we're going to assign a black color for this box view. And we can see that still no control is visible. This is happening because we must also set the height request property. Let's indicate then that we want the control to have a height of 200 units. And now we can see the control as part of the application. This control is going to serve us when we want to place some type of background, for example, in the application or when we want to carry out the separation between two different sections. These are some of the uses that we can give to this control. The following control that we're going to analyze is a control called Label, which surely you have noticed in some previous demonstrations. This control is going to serve us to show text to the user so that he can read it without needing to carry out some type of interaction. The control has a property called text, to which we assign the text that we want to show to the user. It also has some additional properties, such as the color of the text. It has some attributes for the font, as in this case we are applying an attribute for the font to be a bold font. We also have the ability to set the font size, and in this specific case we have different options for this value. We see some default options that refer to a specific size that will be displayed as part of this control. The advantage of using these values from this list is that the value is going to be determined according to the device we are on. That is, if we are on a mobile device, the value will be adapted for that mobile device, while if we are on a tablet, the value will be increased so better display the font on that device. We could then use any of these values, or if we need to, we could use a numeric value, as we see in this case. The recommendation is that you use one of the preset values. We can also assign a property, for example, to determine where to place the text. Previously, we had seen some properties such as horizontal options and vertical options. But in this specific case, when we set horizontal text alignment, we refer only to the text that will be part of the label control, and in this case we are setting the value center. That is, we want the text to be centered. Let's see how the changes look in the emulator. We can see that the label has the characteristics we have set. If we change, for example, the color to an aqua color, we save the changes, we can see how the font color has changed according to the color we have set. Let's change the color back to a black color. Undoubtedly, it is one of the controls that we're going to use the most. Another control that is also part of the framework, which has to do with drawing geometric figures, is the control called Ellipse, which we will use when we want to draw ellipses. For example, if we want to show a user profile, if we want to show some kind of graph or some similar element, we can use this ellipse control. Unlike the box view control, we do not set a background color, but in this case we determine what is going to be the fill of the ellipse through the property called fill. And in this case, we are assigning a dark red color for this value. We can also set if we want this figure to have some kind of contour through the stroke property. In this case, we are determining that we want a dark green value for the outline of the figure. We can indicate how thick the outline is going to be. We can determine the height request and set properties like horizontal options and also it width request to determine how wide we want this figure to be. If we save the changes, we can see the ellipse type geometric figure being drawn as part of the application. As part of the controls that we can use, there is the line control, which will allow us to draw lines. We must specify a stroke to determine the color of that line. We're going to specify the coordinates from where we want the line to start. In this case, we indicate that we want it to start at the coordinate 0, 0, and we want it to reach the coordinate 100, 50. We also set the stroke thickness to determine how thick the line will be, and in this case we are specifying a value of 10. We save the changes, preview the application, and see that the line we have specified is already being drawn. Another geometric figure that we can draw is the geometric figure called rectangle. We can specify a fill for this geometric figure. We determine some additional properties such as stroke, stroke thickness, which we have already seen above. We set the height, the width, the horizontal options, and in case we need some kind of rounding at the corners for the rectangle, we can do it through its pair of properties called radius x and radius y. In this example, we set a value of 10 for each of the corners. Let's save the changes. And we see that in the emulator is already being drawn this rectangle with the characteristics we have specified. As part of the geometric figures that we have available in .NET MAUI, we also have the figure called polygon. For this figure, we establish a fill, and in the specific case of a polygon, we must establish a set of different points that will allow us to draw the geometric figure. If we analyze each of the values that are part of the points of this geometric figure, we will see that we have them in even values. That is, we have a pair of coordinates, then a space, then another pair of coordinates, a space, and so on. This creates the drawing area for each of the points that we want to be part of the polygon. Similarly, we determine through the stroke property what will be the color of the line we are going to draw, and the stroke thickness to determine how thick the line will be. This is the geometric figure that is being drawn as part of the application. I am going to paste a second example for a polygon type figure, and in this example we indicate that the fill is going to be a yellow color. We specify a set of points as well, and additionally we specify different properties that are going to allow us to draw the outline of the figure. For example, we set format to draw a dashed line, the distance of separation of the lines, and let's see how this example looks in the emulator. Here we see how this geometric figure we have specified is displayed. We see that the outline of the figure is not formed by a straight line, but is formed by a dashed line. Also, as part of the geometric figures that we can draw a figure called polyline. We see that it also contains a set of different points which are being determined in this points property, and we have indicate that we want a stroke equal to red. Let's see how this looks in the emulator. And here we can already visualize this control called polyline, which follows the drawing according to the points that we have been specified as part of the SAML file. I am going to carry out the pasting of another polyline control so that you can see another type of graphics that you can draw with this control. We save the changes, and unfortunately, as part of the graphical interface, we can no longer see this control that we have added to the stack layout because it is positioned below the page boundary, and therefore it is being hidden because we cannot scroll the page up. There is a way to add a scroll bar in a simple way. what we're going to do is to group this stack layout inside a view called scroll view. We are going to close the tag, and we are going to place the stack layout just inside this scroll view element. With this, we're going to save the changes, we return to the emulator, and in this way, we can scroll the page to the top, and now we can see the polyline type figure that we have drawn previously. Another figure that we can use as part of the application is a figure called path. And in the case of a path, we must specify a different set of data. We will use a property called aspect so that the figure is displayed in a uniform way, and we must fill in the information of this property called data, which contains a set of different values including even different letters. The creation of figures through paths is a little more complicated, and regularly we are going to use some external tools to carry out this drawing. With these lines that we have added, let's see how it looks in the emulator. And we see that we are drawing this figure that can be seen here thanks precisely to our path element. Another element that we can use as part of the graphical interface is an element called border that will allow us to add a border to any graphical element that is part of the .NET MAUI framework. In the example on the screen, we indicate that we want to create a border on a label element. If we visualize the changes, we see that at the bottom of the application, we have the label control with the text we have specified. However, we cannot see the border yet. This is because we must designate a set of properties for this to work correctly. Here I have pasted some properties. For example, we need to define a stroke. We need to indicate how thick that line is going to be. We need to specify if we want a background for the border, if we want a padding where that border is going to be placed, and also very important, we must specify a property called stroke shape that basically will serve to indicate what type of border we want to establish. In this example, we indicate that we want to use a rounded rectangle, and because this control has a property called corner radius, we can specify a rounding for each of the corners. With the change we have made, we can see that we already have the label element, and around it the border that has been successfully applied according to what we have indicated. We see then this nice border, which has the rounding and the background that we have set, and also the color that we have indicated for the border. Also, as part of those presentation controls, we have a control that you're probably going to use a lot, which is the control called image, which we can use by assigning an origin for the property called source. And this source is going to be a reference to one of the images that are inside the resources folder and the folder called images. For example, we're going to use this .NET bot image, and we can see how the image has appeared as part of the graphical interface. As part of the properties of this image, we have a very important property, which is the aspect property, which will allow us to determine how an image is going to be seen according to the container in which it is located. If we want to fill the entire container in which it is, if we want to fill the space but keeping the aspect ratio, if we want to center the image, or if we want to fill the entire content of that container. We are also going to talk about a control called frame, which will give us a card type format. We can use it in this way, and regularly inside the frame tag, we're going to place some kind of content. In this case, I am going to place the content of the image that we have previously created. I am going to also, as part of this frame, to determine a margin of 5 units, and this is the format that we have when we create a frame control. I hope it looks good. We see a frame with a shading that is containing the image that we have determined. We can apply a set of additional properties to the frame. For example, we could change the background color. Let's indicate that we want a blue color. And another very important property is the padding property, which is the spacing between the internal content and the boundary of the frame control. We can specify, for example, a somewhat height property, for example 10, so that this example looks good. And here, we can appreciate how the visual appearance of the frame element has been modified. It is already a little better appreciated. Finally, we also have a control called WebView, which will allow us to place a URL to display a website as part of the application. In this case, we are indicating a head for this WebView control, and as part of the source for this application, we are indicating an URL. Let's see how this looks in the application. And we see that at the bottom we are already displaying this website as part of the application without doing anything additional. These are the different presentation controls that we're going to be able to use when we create graphical interfaces with .NET MAUI. Let's see now the controls that can initiate commands, which, by the way, is a functionality that we're going to see later in the course, but basically it refers to some controls that can trigger events such as a button. A very common action is that you can click on it to execute a certain action. So let's start looking at those controls. And for this video, I have created a new page called Commands Controls Demo. I'm going to proceed to copy and paste some of these controls. I'm going to leave the stack layout element again, and we're going to start by analyzing this control. The control is called button. It is possible, as we had seen previously in a video, to assign a name to this control through x:name. We specify what is the name of this control, and we also have the possibility to assigning a text that is going to be shown as part of the button through the property called text. Additionally, we have an event which refers to the fact that the control will react in a certain way when we interact with it. In this case, when we click on the button, a certain action will be performed. How can we determine this action? Well, if we specify the event click equal to, we will get an option to create a new event handler that will be created as part of the code of this page. We can navigate to the code behind quickly by pressing the F7 key, and in this way we navigate directly to the code behind. This is the event handler that has been created as part of the clicked event, and this is where we code the logic to perform a certain action when we click on the button. For example, we have available a method called displayAlert that will allow us to display a message to the user. This method requests a title, a message, and a string for the cancel button. We can set a title equals to test, a demo text message, and as part of the message of the cancel button we place the string OK. Let's start the application. And once the application has been deployed, we already have in the upper part the button that we have specified. If we click on the button, we see this message being displayed, showing us each of the strings that we specified as part of the displayAlert method. The next control that we're going to analyze is one very similar to the button element. It is the image button control. In the case of this control, instead of setting a text as part of the button, we can set the source property. We're going to indicate that we want to use the image that we have used previously called .NET Bot. You could use your own image if you wanted to. And again, we set the clicked event. We can reuse the same event handler that was defined earlier as part of this button. We visualize the changes once again. And this is what the application looks like. This does not look like a button, but if we click on this image that we are viewing, we are shown again the message that we have previously set. Ideally, you should specify an image that is more descriptive and that gives to understand that it is a button. In the same way, we can use a control called radio button. I am going to proceed to format this text a little better so that it looks in a better way. I'm going to stop the execution, and as part of this control we have a property called content, which is going to be the text that is going to be displayed as part of the radio button element. I'm going to quickly remove this property called group name, and I'm going to show you also another event that is part specifically of this control, which is the checked event. This event is going to let us know when the user selects one of the radio buttons. In this way, we will be able to determine if a certain option was selected to show a different graphical interface, for example, or to carry out some similar action. In this case, I am going to proceed to recreate this event handler, removing this definition that I had previously, and we are going to proceed to create it. If I go to the code behind, we see this event handler. I'm going to proceed to copy and paste a display alert that looks very similar to the one we had previously, only instead of showing this text that says this is a demo, we have indicated that we want to show what is the value that has been selected. Let's proceed to start the application again, and we can already see the control that has been created, which is this radio button. If we select the option, we see that we are already shown this message that the element has been changed. Now I will proceed to copy and paste this element 3 more times to test some other features. I am going to change the content message, and we're going to visualize the changes. The different options already appear, but notice that if we select any of these options, we only have a group of options. What would happen if, in such a case, we need to have other groupings to be able to make a selection between different elements? Well, what we can do is to set the property called group name. We're going to place, for example, group 1 as group name to this first radio button. We're going to do the same with the second radio button, but with the third radio button, we're going to indicate that we want a second group. We're going to change the group name to group 2. And if this time we select one of the elements, notice that we already have two different sections where we can select each of these options separately. Another control that we can use to initiate commands is this control called search bar. Here we have indicated that we want a name for this search bar, and we have an event called search button pressed, which is going to initiate the execution of a certain action. Let's create this event handler by clicking on New Event Handler. Let's navigate to the code behind. I have pasted a display alert that is going to show us the title searching, and as part of the message it is going to indicate us which is the search term that we have entered. Let's start the application, and here we have the search bar. If we position ourselves on it and click on it, the keyboard will appear so that we can enter some term. For example, we're going to insert NET MAUI, and when we press this search button is when this event handler is really going to be executed. Then we click on it and the term that we have searched for appears. Finally, we have a control called swipe view, which will allow us to have within the content of the swipe view a main content, which can be a layout or a set of controls, and we will be able to move to the right or to the left the main content to display different options and execute certain action according to the pressed element. It is very common to see it in applications where we have emails. If we scroll one of the elements to the left or to the right, options appear, for example to delete the message, to forward it, or to reply to that message. These types of actions can be replicated thanks to the swipe view. We must specify as part of the properties of the swipe view if we want the elements to be displayed to the right or to the left of the element, that is to say, to modify the property left items or the property right items. We're going to test with the left items property, and as part of this property we must specify which are going to be the different swipe items. This is going to be a collection of different options that we're going to be able to display to the user, and we must specify a swipe item to indicate a specific action. I am going to replace this code with a code that I have previously created, and we specify some properties for each of the items. For example, its background color. We also specify an icon if we have one. We are going to use the same icon that we have been using, .NET MAUI. We also have a property called invoke, which is the event that will allow us to initiate a certain action when we select one of the elements. For example, delete the element or forward a message. We have defined a second swipe item element with a different background color. I'm going to copy this same image for the icon image source. And since we have defined each of the options of the swipe view, we must define what is the main content of the swipe view. In this case, I am going to indicate that the content is a grid element, and as part of the grid we nest a label control with a text and some horizontal and vertical options. Once we have established the content of the swipe view, we're going to define this pair of events that we have not defined yet, which are the ones that are as part of the invoked event. Let's create the event handler, go to code behind, and as part of the event handler, I'm going to indicate that I want to use a display alert showing that one of the elements was selected. We start the execution to see how this example is seen in the emulator, and we can already see the main content of the swipe view. We can scroll to the right that content and we see the elements that appear in the part of the left. As we had specified, each of the options has a background color, a text, and an icon. If I click on one of the elements, we can see the message displaying that we have selected one of the elements. In this lesson, we're going to learn about the controls that will allow us to set values as part of the application. For this lesson, I have created a new page called Input Controls Demo. I am going to proceed to remove this label element, and in its place, I am going to paste a tag to create a control called checkbox. We have as part of this control a property called isChecked that will let us know if the checkbox is selected or not. Once the application has been deployed, we can see the checkbox control selected, since we have indicated in the isChecked property that the value is equal to true. As part of this control, we do not have the possibility to set a text. If we want to set some kind of text, we must add an external control such as a label control. The next control we're going to examine is a control called slider, which will allow us to set a value in a slider element. As part of the properties of a slider control, we can set a minimum, a maximum, some colors for the control that you're going to see in a demonstration. And we also have an event called value change that is going to be fired when we change the value in that slider control. In order for the example to work correctly, I'm going to recreate this event. And I'm also going to proceed to create a label element that is going to let us know what the value of this slider control is. We have to assign a name to this label element to be able to access it from the code behind. Let's go to the event handler that we have created and I will proceed to set the content. In this way, I indicate that I want to use the LVL slider control, which is the label control that we have created to show the information, and in its text property, I want to show the information obtained from the slider control in its value property, and I'm going to make a conversion with the toString method so that we do not have problems with the conversion of values. Let's proceed to start the application to see how the change we have made looks like. And here we can see this slider control as we have set it up. I'm going to proceed to drag this circle that is part of the slider control, and at the bottom we can see how the value is changing as we are getting the current value of the slider element. Also, the different colors that we have established in the XAML code have been applied. Similarly, we have an element called stepper that will allow us to select a specific numeric value in the application. We're going to proceed to stop the execution of the application because we want to recreate this event handler. As part of the control, we can set a maximum value, a minimum value, and even what is the increment that will happen when we click on one of the buttons of the control. For this demonstration, we're going to reuse this label element. Let's go to the code behind. I am going to paste some lines of code where I am validating that the instance of the stepper is not equal to null. And inside this validation there is a line similar to the one we have at the top, only that instead of using the slider control, the stepper control is used. Let's see how the application looks like when we run it. And this is what the control looks like. We have a couple of buttons that we can press to increment the value that is being displayed as part of the label. See how the increment is given in pairs, since it was what we specified in the XAML code. We have maximum value, that is the value 10, and we have a minimum value 2, as we specified in the XAML file. As part of the controls, we also have a control called switch that has the isToggled property to know if the control is selected. Here, we can see it in action. We can see that we can select and deselect. We also have a control called datePicker, which is widely used for the selection of dates, and a control called time picker to select an hour and minutes. Let's see how they look in action. And here they are being displayed. We have this pair of lines that show us what the current date is. We can select, for example, the first control and select a different date. We can also select the second control to select a specific time. And this is how we can work with these controls in a very simple way. Let's analyze now the controls that are going to allow the user to enter text as part of the application. For this demonstration, I have created a new page called Test Controls Demo, which I have assigned as the main page. I am going to proceed to remove this label element, and instead I am going to indicate that I want to use an element called entry. This is a control that will allow us to enter text in the application. If we start the application, we see at the top this text box that will allow us to enter text. We can assign certain properties to this entry control to modify the visual appearance. For example, we have a property called placeholder that will allow us to assign a text so that the user knows what information to enter. We can also modify the color of the placeholder through the placeholder color property. Let's set a dark green color. And if we want to see this color in action, we must remove the enter text, and we already have here the placeholder. Also, as part of the entry element, we can indicate if, for example, we want the content to have a password format, that is to say, to hide the characters of the text that are entered. This way, we do enter some text. Notice how the text is hidden immediately. And another property that is very useful is a property called keyboard, which will allow us to specify what type of keyboard we want to show the user so that he does not enter incorrect information. For example, we could indicate that we want to use the keyboard so that it can only select elements of a telephone number. If we see it in action, here is this numeric keypad being displayed for entering only numbers to form a phone number. Also, as part of the properties of an entry element, we have two events that you probably want to know about. The first event is the event called text changed, which is going to fire every time a character is entered in the entry control. We're going to proceed to create the corresponding event handler, and we also have an event called completed, which is going to fire only when you finish typing a text in the entry control. I'm going to proceed to go to the code behind of this file, and let's test first the event called entry text changed. We have to import the namespace that is needed so that we do not have any type of problem. This namespace is system.diagnostics. And we're also going to set an X name for the entry element to match the name used in the code behind. That is, the name txt name. With these changes, let's start the application. I'm going to start typing text into the entry control, and it seems that nothing happens. But if we go to the output window of Visual Studio, we can see the different characters that have been pressed from the keyboard. That's how this event called text change works. Also, as I mentioned before, we have the event called completed, which is going to work only when we finish typing the desired text. I'm going to copy this line to the entry complete event handler. Let's restart the application. I'm going to type some number, and this event will fire only when we finish editing the control. For example, by pressing this green keyboard control. We go to Visual Studio, and as part of the output window, we see the number that's being typed in. This is the difference between using this pair of entry control events. Finally, there are going to be times when you want the user to be able to enter multiple lines of text. For example, if you wanted to enter a comment or you wanted to edit a blog post. And for these occasions, we can use a control called editor. If we visualize this control, we see that it is very similar to the entry control. However, as part of the properties of the editor control, we have a property called auto size, to which if we assign the value of change, it will allow us to resize the control as we write in it. Running the application, observe how, while we write, the control becomes bigger as we increase the amount of text. We also have the pair of events text changed and completed that we have already seen previously. In this lesson, we're going to learn about those controls that are going to allow us to indicate certain activity to the user so that it does not think that the application stopped working. For this lesson, I have created a new page called Activity Control Demo, which is a content page. I am going to proceed to remove this label element, and instead we're going to meet the first activity control, which is the control called Activity Indicator. As part of this control, we have a property called isRunning, which will allow us to indicate if we want to show the control or not. And in the same way, we have a property called color that will allow us to set the color for this activity indicator. Let's see how it looks in action. Here we can already see this control that is the activity indicator, which could be shown to the user to indicate that a certain activity is being executed. We return to the SAML code, and as part of the controls also of activity, we have a second control called progress bar. And unlike an activity indicator, we can assign a property called progress, which will allow us to establish what is the current value of the progress bar. If we see it in action, we are seeing this bar displayed, which is indicating that the progress is 50%. If you had to choose which control to use between the two, the answer is simple. If you know how many tasks have to be executed before the completion of the activity, then you would have to use the progress bar control. But if you don't know how long the whole process will take, then you should use an activity indicator. In this video, we're going to analyze those controls that are going to allow us to display collections as part of the application. First, we're going to study a control called Carousel View, and for it I have created a new page called Collections Control Demo. That is the one that we have placed as initial page, and it is this one that we are seeing in screen. We're going to create a control of this type, changing the control label by the control Carousel View. When we work with this type of controls that allow us to display collections, we need to use a data source, and there are different ways to assign the data source to a collection. Because we have not yet reached the topic of MVVM, we will proceed to define as part of the carousel view a property that is called item source. In this property, we can define a collection or an array of items as part of the information source. In this way, we are declaring an array containing only text strings, and through this syntax we have added different elements to the list. In this way, we have filled in the data source information for the carousel view control. Let's see how the application looks like. And here we can see the control being displayed. We can scroll the different elements of the collection, but realistically this doesn't look very good. We need a way to assign some kind of layout to the collection of elements. Fortunately, there is a way to do this. Let's go back to the SAML code. And as part of this control, we have a property called item template, which is going to allow us to define how each of these elements that are part of the collection are going to look. And as part of this property, we must define a property called data template to begin to define the visual appearance of the elements of the control. Regularly, a layout is usually used to be able to define designs composed by several controls in the data template. In my case, I have already created a layout called stack layout, and inside I have simply created a frame with a label control. You can see that in the label control, we have assigned to the text property a little strange syntax that we have not yet studied. But what we are doing in simple terms is to link each of the elements that are part of the list to a label element. If we visualize the application at the moment, we can see that we can already move between each of these elements, and each of them has a completely different appearance to the one we had at the beginning. Now, a problem that we currently have with this carousel view control is that we have no idea in which element we are. We don't know if the current element is the last one, if it is an element near the beginning, or what is the position of this element. There should be a way in which we could know in which position we are. to know, for example, in a step-by-step tutorial in which step we are. Fortunately, there is also a way to do this thanks to the .NET MAUI framework. And to add an indicator linked to the carousel view, we have to define a control called indicator view. I'm going to paste a piece of code that contains an indicator view control. We are assigning a value to horizontal options, we also set a color for the indicator, and likewise, we're indicating that we want to set a color that gives us an idea about the position that we're in. Also, something very important is that we are assigning a name to this control, since we're going to use it later. If we currently go to the application, we still cannot see the indicator view control. The problem is that, although we have defined it, we have not specified what is going to be the relation of the carousel view with the indicator view. Notice that they are not part of a hierarchy. So, we must use the name of the indicator view control to indicate that this carousel view control is going to have a relationship with this control. And how can we do this? Simply using a property called indicator and passing as parameter what is the name of the indicator view control, which in this case is indicator view. You must use the same name specified in the property xName of the indicator view control. This way, let's see how the application looks like. And we can already see the carousel view control, but this time it is already showing the indicator view that indicates us in which element we are. We have a color for the indicators, and we have a different color for the current element. This is how we can implement an indicator that is related to the carousel view and that allows us to know in which element we are. We're going to see the second type of control that is going to allow us to display listings. I am going to proceed to comment this code that we have pasted previously, and I will also comment this stack layout, since normally a listing uses all the available space in a page. So I'm indicating that the main element of this content page is going to be the listing. As part of the listing, we are once again defining the data source. In this case, we define an array of strings as we did with the carousel view, and we also define through the item template property how this list of elements is going to be seen. In the specific case of the list view control, we must define after the data template tag a special tag called viewCell that will allow us to customize how each of the rows will be seen. And then what we are doing is to use the same code that we had for the carousel view, only this time we're going to define each one of the rows for a list view type control. With this change, if we return to the application, we can see that we already have the list of different elements. However, the words that are part of each row do not look good. This is because each one of these elements has a different height, therefore we must return to the list view control and we have to specify the property has uneven rows equal to true, so that the elements are displayed in a better way. This way, we can see how the elements are displayed in a better way thanks to the use of this property. Also, we can select each one of the elements to carry out some type of processing. I am going to proceed to comment the list view section, and we're going to see another of the controls that allow us to manage data lists. It is the control called collection view. The collection view is a control that came out after the list view control in the original Xamarin Forms framework, and as part of this control, we will also define an item source. We're going to define an item template, but the difference is that in this specific case, we don't have to use a viewCell tag, but directly after the data template, we can define a layout to define each of the items that are going to be part of the collection view. Once again, we are reusing the layout we have seen previously. Let's see what this looks like in action. We can view the list using the collection view control from the information and layout we have assigned. If we try to select an item, we cannot do so, as we must enable a property as part of the XAML code. This property is a property called selection mode, which by default is set to none. If we wanted to be able to select a single element, we could do it through the single value, or If we wanted to select multiple elements, we could do it through the multiple value. For example, let's select the single value, and if we go back to the application, we see that we can select one element at a time. If we change the value back to a multiple value, we will be able to select multiple items from the list. Another great advantage that this control offers us over the list view control is that we can create columns. Here we see the next control, which is the control called picker. We are defining it inside a stack layout element, and for the case of this control, we define its vertical options. Again, we define a data source, which is the same list of strings to fill in the information of the picker control. Once we go to the emulator, we can see the control that we can select, and that is going to show us the set of different elements that we previously indicated in the list of strings. If we select one of the elements, it will be the element shown as part of the picker control. Finally, we have a control called table view. I am going to proceed to comment this code once again, and I'm going to paste a definition of a table view control. This control will allow us to display a table of elements to define different sections. A control of that type is normally used to show elements in which each row has a different appearance, like a menu of settings of an application, for example. Here we can see how it is implemented. We have the table view control, to which we have to assign an intention. That is what we're going to use it for. We can use different values. In our case, we're going to indicate that we want to use the table view as a configuration table. We must define a table root element and later different elements of type table sections, which are going to be the different sections of the table. Within this section, we will define each of the controls that are part of that section. Unlike the previous controls, we must use special controls within the table, such as this one called text cell, which contains a text type property for details and a property to assign a main text. We also have a control that allows us to enter information called entry cell. Here we can establish what is going to be the information text for the entry element and what is going to be the text entered for this control. We also have a control which is a switch cell type control, to which we can define an information text. And also to specify an image, we can use this control called image cell. We can define a source, which in this example is going to be the one we have used called .NET-bot. We define a second table section, which is the same as the one we have previously analyzed. Let's see how this is displayed in the emulator. And here we can see what this table looks like with each of the elements that we have defined. We have in the first place a text cell that shows us only information. We have an entry cell element that allows us to enter information. We also have a switch cell that allows us to select a value as true or false, and we have an image cell to display an image as part of this form. And this is how we can create this type of pages easily, in which we can use these cell type controls that are already configured to fill the tables in a very fast way.